All right, so this video is hopefully going to help us out in preparing for our Show What You Know 1.2 reassessment. I'm not going to do each problem fully, but I'm going to start us off on them and need you to finish them and prepare on your own a little bit, but I'm definitely going to get you started. So for working on number 1, it says determine the measure of each segment, then indicate whether the statements are true or false. And so I know that measure of a segment is length or distance. So I'm going to be using the distance formula here. Then we have AB is congruent to JK. So these are the statements that we're going to say whether they are true or false. And remember that that symbol in the middle, equal sign with the squiggle, does mean congruent. So to figure out whether two segments are congruent, I'm going to find the length. And I cannot count that length. I need the distance formula. There is one length that I can count, and it would be whether the segment was horizontal or vertical, going with the grid marks. So I count here and see that this grid mark is 5 units long. So I can count the length of JK. I can then use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. And to use the formula, I am going to want to have two ordered pairs, which are, if I'm finding the length of AB, those ordered pairs will be negative 4, 4, and 2, 5. And these are my x1, y1, and x2, y2 when I'm plugging it into the formula. So we'll find the length of AB using the distance formula. And my x2 is 2, and then my x1 is 1, so or negative 4. So I am subtracting negative 4. I have my double negative there. I'm closing and squaring it. And then I'm going to take my y2, which is 5, and subtract 4, close it, and square it. When I work this out, I get 2 plus 4 is 6. I still need to square it, and 5 minus 4 is 1, which will be squared. Working these out, I get 36 plus 1, and that is still under the square root. Add them together, and I get square root of 37. Now, this is not a perfect square. If it was, I would, of course, want to get the answer in integer form, whole number form. And if it isn't, then I can use a calculator and get the decimal estimation for this number. But I also will know when I find the length of GH that if I get square root of 37 before simplifying or getting the decimal, then I would have a congruent segment. But just to remind you, here are our perfect squares, and if you get any of these numbers, you're definitely going to want to make sure to put it in integer form. So I'm going to leave you at this point in the problem. To complete the problem, you are going to want to find the length of GH. So we already have JK and JK and AB. To find GH, we are going to need the ordered pairs. You're going to repeat the same process that I just did and see whether you get square root of 37 or something else. Because we have the length of AB and JK, we can answer part A, which was whether segment AB is congruent to segment JK. And we can see that since we got square root of 37, which is not equal to 5, that would have been square root of 25, that AB is not congruent to JK. So we can mark false on that first one. And we will need to finish up with this one on our own. And we're going to be moving on to number 2. Feel free to fast forward in this video whenever you need to get to the problem with the help that you need. So we're going to be finding the perimeter of triangle ABC. Rounding to the nearest hundredth is if necessary. We are using a very similar process to what we did in the last problem. If there is a vertical or horizontal line, we can count it. If it's diagonal, we cannot. And we are finding the lengths to get perimeter, so we're going to need to know the lengths of all 3 sides, AB, BC, and AC. If we add those up, then we will have the perimeter of triangle ABC. We can see that AB and CB are both those horizontal and vertical lines that allow us to count the length of 3 and 4. But with AC, we will need to use points and the distance formula The ordered pair for C is -6, 1, and the ordered pair for A is 2, 4. And so with these points as your x1, y1, and x2, y2, you're going to want to calculate the length of AC. Notice the direction says round to the nearest hundredth. Now, if you get a perfect square, which is an integer, there will of course be no rounding necessary. But if it is not a perfect square, then you should be rounding to the nearest hundredth, which is 2 decimal places. So a couple more steps for you to take here, finding the length of AC and adding those together. And on to number 3. What is the midpoint of points L and V? Now, this is a straightforward midpoint formula problem. We can use the formula. We also have the use of the coordinate plane to help us in double checking whether our formula work is correct. And I'll show you how to do that. So we have our formula here, midpoint formula. Still have x2, x1, y2, y1, like in our last formula, but now we are adding and dividing by 2. This is a point, so my answer is in the form of a coordinate x comma y, and that's why we have these 2 expressions that are making up the 1 point. I see that L is 1, 1, and V is 3, -2. And I'm going to plug those into the formula, or you will rather plug those into the formula to find the midpoint. Now, one thing I do want to highlight is that you can use the coordinate plane to help you in the process of finding the midpoint or checking on your midpoint. You can graph it to see if it looks like it's in a reasonable location for midpoint. And you can also entirely find the midpoint by using a coordinate plane. If I look at the horizontal and vertical distance, a midpoint is going to be found where half of those distances lie. So I can actually take half of 3, which is 1.5, and half of 2, which is 1, and get the location of the midpoint. So if I go 1.5 spaces down from L and 1 space over, I land at the midpoint of LV. I can see that the distance between the midpoint, both vertically and horizontally, is the same when looking at L and V. All right, a couple more problems left of this assessment. So we have number 4, ST, segment ST lies in the coordinate plane with S located at 3, 2. The midpoint of ST is Z at 3, 9. Can the location of T be determined? So I do want to suggest that you go ahead and graph this if you haven't, just to check it out and see how the visual confirmation you can get as we did in the last problem. But in this problem, it is a bit different because we are given the midpoint of ST, which is Z at 3, 9. So we're actually not given the other endpoint, we're given the midpoint. And we're asked for the location of T, which is the other endpoint. So this isn't a exact location of where these are, but if I just think visually of the situation, I have a point S, a point T, and I have point Z in the middle, and I'm looking for point T. I know that Z is going to be equal distance from both S and T. So if I can, find out what that distance is, I can then replicate it and find point T's location. So it can be determined, and we're going to do that by looking at, how much our points have changed. So to get from 2 to 9 as a y value, we added 7. So that would indicate that the point has moved up 7 spaces. And then if I look at the x values, I see that it's 3 and 3, which is no change. So I'm staying on the same x value, and that would lead this to be a vertical line if I'm looking at it on a graph. So if I take the location of z and replicate this same distance, I will have my ordered pair for t. So if I take 3, 9 and add 7, I will be at 3, 16. Remember, I'm not changing the x value, just the y. So this is the location of point T. Again, I encourage you to try that one on the graph just to see that visualization. So on to number 5, we have some vocabulary to fill in. And it says that J is the blank of PQ, and I can see that J is actually right there in the middle. I know that by these tick marks that are showing me that the two segments are the same length. And so I could say that J is the midpoint of PQ, of segment PQ. Part B asks what segment XY is in regards to PQ. And I can see that this line segment is formed where the arcs from the compass are crossing. And so I know this is a particular construction that we did, and it is called a perpendicular bisector. So it cuts that segment PQ in half. It also does that in a way that intersects at a 90-degree angle. And finally, we have part C, which is what are the congruent segments. And I know if it's a bisector, which means the segment is being cut in half, that from P to J and J to Q are congruent segments. These are the two halves of the bisected line segment. All right, we have one question left, and while I'm not going to do this one on this video, I do want to just make sure we clarify, seemed like the part that maybe seemed to mess people up or that was tricky was the fact that this is asking for AB plus 2CD, and we, in our examples in class, added two segments together. So we're actually asking for CD to be added twice. So when you complete this construction, you should take AB plus CD and plus another CD. Now, if you're needing extra help on constructions, there is a post in Canvas, and I hope this was helpful.